as strong as maybe steel, but yet very light, hopefully. Okay? So if that is the case, in the future your car will be made by plastic, which having polymer inside. Anyone having cell phone? Anyone don't have cell phone? No, everybody has cell phones. Okay, you call mobile phone now. In US call cell phone. Inside you have a battery. And what makes the battery last longer is carbon nanotubes. You will find about 1 to 2% of carbon nanotubes inside the battery of your cell phone. If you wanted to know more about this is a book that I made and prepared. It will be published in, I think, June or July this year, right, by Springer. If you go to Amazon.com, you can Google B-C-N BCN. You'll come up with my book. Or you can Google my name. Right? Google my name, Yoke. You'll come up with this book. This will cost $100 US. So ask your library to buy one. It will give you all the information about carbon, boron, boron, etc. And also I talk about this zinc oxide to your friends. This is a book that we published, and if you're interested. As I told you, you have the belt for your nano toy, nano robots. You have the comb their hair. You have the sword for them to fight. Okay, this is nano, everything nano, by zinc oxide. And we use them to build field effect transistors, right? And we even convert silicon to nanotubes. And these are the sponsors that sponsor my research. But just before that, I hope you can get it done, downloaded. Yes! We are lucky. Alright, this is how nanotubes grows, okay? All you need is a catalyst on the substrate, right? And you need some hydrocarbon gas, in this case C2H2, which is called acetylene, the gas that you use for welding. Okay? So if you have the C2H2 gas coming in, then they touch with the catalyst that is melted. They will dissolve inside the catalyst. Just like you dissolve salt inside water. Then when the water becomes saturated with the salt, it will start to segregate and come out with the carbon nanotubes. So this is energy. Okay, thermochemical vapor deposition based on the so-called vapor liquid solid mechanism, right? You have a substrate with the catalyst thin film, and you heat it up to form a catalyst that partially melted, right? And all the atoms C2H4 will come in and will absorb on the surface. Uh-oh. It takes time to play. Internet. Do we have to wait? Well, unfortunately, we have to do that. And this is my research program, Shanghai, and thanks for your attention. While we waiting for this to play, I can take some of the questions that you have. Okay? You can keep watching this one, and you can keep asking questions. Any question? No question. Yes?
So, using the chemical vapor deposition, right? As I read from the book, we can able to use to make either single wall or multi-wall carbon nanotube. But it do depends on the temperatures. In what range of temperatures we can able to use to make single wall or carbon nanotube, and in what range of temperatures we can able to make multi-wall nanotube?
Good question. Sounds like you are not doing research. A very good question. Now, you should come to my first talk. I shall talk about how to control the nanotubes, 1 layer or 2 layers. Okay? Now, the diameter of the tubes depends on the diameter of your catalyst. Okay? And you know that to make nano catalysts, you need very nice control on the temperature. Okay? But now, if you have very small catalysts, which means there are many more atoms located at the surface. The ratio of atom located at the surface compared to atom inside the bulk will be large, huge. So this nanoparticle become very unstable. They tend to move, or they even tend to evaporate. They don't want to stay at the solid. So what happens is that one good way to make them stable is all the small particles, they will join together. We call aggregate. They all join together to form a big particle. When they form a big particle, the ratio of surface atom to the bulk will be smaller and they become stable. So if this is the case, if you have too high a temperature, all these catalysts, small catalysts for single wall nanotubes is not stable, they will stick together. And they will form big particle and you will grow multi-wall nanotubes. Okay? So too high a temperature is not good for single wall nanotube. At what temperature range? We cannot tell you. It depends on your catalyst, depends on types of hydrocarbon you use, etc. Okay? But as I told you, nanotube is a sheet of graphene that you roll up, right? You roll it up. Graphite is very stable carbon. They are flat. They just have layer of them flat. They are stable. Why? Because they are stress-free, flat. But now if you fold them to tube, there's a lot of stress. You know? Let's say this is a piece of plastic, you fold them. You are actually applying stress to the sheet. Single wall nanotubes, the diameter will be very much smaller. So the curvature is very small. So very high stress. So to overcome the high stress, you need more work, you need more energy to do that. To do that, you need high temperature. So that is controversy. You need high temperature to fold this to a small diameter single wall tube, but too high a temperature, you will make all the nanoparticles to join the big particle, and you cannot make single wall nanotube. You get what I mean or not? So it's controversy. Okay? So we come up with a smart way. I think we are smart to do it. I talked in the first part, right? I have aluminium under the layer so that the small particles sink inside and they cannot move very easily and they will stick to form the big particle. Since this is not good, maybe I can show you the now this is the animation that I can show you, not animation, just a drawing to explain this. Okay, this is the one. Now you have the small catalyst, right? At high temperature, figure A here, they tend to join together, right? They merge together, become big particles. So you will grow multi-wall tubes instead of single wall. And now you put a layer of aluminum underlayer. And this small particle will sink inside. Okay? Further, only portion of the surface can expose for the growth. So in this case, you prevent them to merge the big particles. And at the same time, you can control how big is the surface exposed for the growth. So in this case, you can grow single wall or multi-wall. Okay? And all this can be done at the same temperature. Alright? So if you ask me what temperature range, not exact. Okay? But for the growth, typically around 600 to 800 degrees Celsius. Thank you for the questions. Anything else? As I say, no question means you understand everything or you don't understand anything. Okay, it's already 12 o'clock, maybe you're too hungry. If you have questions, feel free to ask. Otherwise, thank you for your attention. Thank you.